At this point, we have entered in over San Francisco, California, and are very quickly going to be approaching the Utah Test and Training Range just a little bit further to the east. Entry was at
EO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning scalding hot on that heat shield that is protecting our sample within, and maximum deceleration that is at 32 g-force, punishing deceleration from Earth's atmosphere, the drag forces that are acting on that SRC. Once again, as I mentioned, that sample is safe and sound within that SRC, that sample return capsule, as it comes in, burning through Earth's atmosphere. You can see our high altitude plane searching for that SRC. You can see it faintly on your screen there. Our next milestone, we'll be expecting that drogue parachute deployment. That'll be at about 102,300 feet altitude. And as I mentioned before, that will stabilize our descent and slow us from hypersonic to subsonic speeds as we continue to target the Utah Test and Training Range.
Expected EDO milestone. SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute. Waiting to see that visual confirmation, but that is at 102,300 feet. And a side note, at this time, 8:44 a.m. Mountain Time, the OSIRIS-REx spacecraft is at its closest approach to Earth. That will be on to its extended mission, visiting the asteroid Apophis in the year 2029, continuing this incredible mission at another world. And in just a few moments, we should enter into special use airspace at approximately 8:46 a.m. That's going to be at 10 miles off the deck here at Utah Test and Training Range. You can still see that SRC on your screen very faintly in the distance. Still quite warm, that fireball that literally was a ball of plasma just a few moments ago when it first entered into the Earth's atmosphere. That SRC is nearly 3 feet wide, 1.6 feet tall. It's a small object, so quite a challenge to track this as it comes searing into Earth's atmosphere. And in just a few moments, we should be entering into special use airspace. This area was specifically chosen for this mission. It's a wide open, vast desert space, relatively flat, perfect to land this sample today. We did, as I mentioned, have a couple days of rain here leading up to this event, so the ground is a little bit soft. You can see our SRC. Streaking in. This is from our high altitude cam. Our next milestone, we should be expecting main parachute deployment at around 8:49 a.m. Mountain Time. That will be at around 5,000 feet elevation. We continue to track with our high altitude camera here. As I mentioned, that sample is thermally isolated within that SRC, a very complex labyrinth network of piping and tubing leading into that sample canister within, that just a few years ago was on the other side of the solar system from us sampling at Asteroid Bennu. The team has incredible precision on this mission as well. Just a few days ago, on the 17th of September, they did their final trajectory correction maneuver, TCM-12. This corrected our velocity by 3 millimeters per second. Sweet delight to see in our sky here over the Utah Test and Training Range. A phenomenal view, just wonderful to see that deployment. That is at around 5,000 feet elevation above the Utah Test and Training Range. And now this is like a marathon runner savoring that last lap here as we approach the finish, that landing in the Utah Test and Training Range. Wonderful to see that. We continue to track. This is with our high altitude camera still, that WB-57. And we should have a great view from here on the ground. We've got a variety of different tracking assets. And you saw Sophia out at the edge of that ellipse watching from Wig Mountain. The team there could potentially have a wonderful view momentarily as well. We'll continue to descend. Our next altitude descent will be at about 4,000 feet. Just a few minutes away from getting that sample from the other side of the solar system, from the surface of asteroid Bennu at sample site Nightingale to the rugged terrain of the Utah Test and Training Range. Looks like winds are relatively low. Not a lot of rocking back and forth. Those parachutes seem to be perfectly smooth coming down, that parachute there. Continuing to descend, the slight little bit of tilt back and forth of our SRC as it comes to its resting velocity of 11 miles per hour as it makes that final descent. That parachute deployment was given internally by the spacecraft. All of what you're seeing now is autonomous on board that SRC. And once that successfully lands, the teams will begin the next crucial phase of this mission, the sample recovery operations. They've been rehearsing for this moment for months, literally years really, leading up to this key moment, and are ready to begin those operations to get that SRC into our portable clean room here and extract that sample canister within. According to my watch, we're about 5 minutes away from landing with our SRC. And as we heard a few moments ago, helicopters 1 and 2 are already staged and ready to begin those recovery operations just as soon as we have confirmation of touchdown. This is a variable clock, so this could be a little bit faster, a little bit slower as we get closer in. This wind speed here is a variable that is quite hard to predict, especially once you're high up in the atmosphere. We did release a weather balloon earlier on this afternoon, or earlier on this morning rather, to get a profile of our atmospheric conditions. The team puts those into various models as they prepare for this key moment. But once again, they are a little bit hard to predict, a little bit of variability, so we may kind of bounce around a little bit on that predicted OSIRIS-REx sample return capsule touchdown time. The ground really closing in now on that SRC.
EDL milestone. Helo 1 has visual on the SRC below the chute.
That is phenomenal. Let's see that view here from that first helicopter. They've got visual on the sample return capsule under parachute, that orange creamsicle colored parachute, really bright in the morning light over the Utah Test and Training Range. A great view of the SRC we can have now from our helicopter as it continues to make its final descent to the terrain below. And once again, just setting the context for this, when we first hit the top of the atmosphere, we were at 27,650 miles per hour. We are now leisurely decelerating under our orange parachute to 11 miles per hour. Incredible amount of deceleration there as Earth's atmosphere really helped us out quite a bit, getting that initial deceleration, our drogue parachute initially stabilizing our descent, and then ultimately that main parachute bringing us home. You can see right in the center of that crosshair, that is the parachute with the SRC dangling beneath. The team on the WB-57 doing
EDL
a great
milestone.
job.
We have touchdown. I repeat, EDL SRC has touchdown.
And touchdown of the OSIRIS-REx sample return capsule. A journey of 1 billion miles to asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system. Unofficial touchdown time, 8:52 a.m. Mountain. And the team can now breathe an immense sigh of relief. We now have the sample return capsule, the SRC, containing pieces of the asteroid Bennu. You see the reaction there just moments ago as they got that sample back on the ground. This is the team at Lockheed celebrating that momentous achievement of getting that sample from the other side of the solar system at asteroid Bennu. When we took that sample, we were over 200 million miles away from us here on Earth. The long journey back, 1.2 billion miles from asteroid Bennu, back to here with that sample, has just come to a dramatic close. And a little bit ahead of schedule, too. The SRC landing about 3 minutes ahead of when we had originally predicted. It was in a rush to get back here, carrying amazing amount of scientific information within. The team is eager to crack that SRC open, get the sample canister within, and begin the process of understanding the origins of our solar system and potentially the origins of life. We're not in the clear just yet. A key piece of the mission is about to get underway. This is the recovery operation phase. Once the team has officially confirmed the exact touchdown location, they'll be flying out on 4 separate helicopters and will operate much like a Formula One pit crew, if you will, to recover the SRC, take environmental samples at the landing zone, the LZ. Everyone has a role to play. It's going to be simultaneous action as they get that SRC recovered and begin to do an environmental safety sweep, collecting samples along the way. You see our mission ops team just next door. I once again remind you that the sample canister itself is not actually going to be opened here at Dugway. The next phase of the operation is simply to get that SRC into the portable clean room that has been specifically set up for this recovery operation. The team will then remove the heat shield protecting the SRC and its precious cargo within the entire descent through the entry, descent, and landing, remove the back shell, and then extract the sample canister within the tag sim that just a few years ago collected pieces from the asteroid Bennu.